Hello, my name is Olivia Thomas, and I'm here to show you Chordbook, which is an app that I designed as a chord reference for pianists. There are a couple of different ways that the app allows you to get information about chords, and I'll go through all of them. The first is Explore mode, which allows you to look at a list of all the chords that are in the app. Right now there's a few, but I'm definitely planning on adding a lot more later. And you can see that favorite chords have a little heart by them, and that's all being saved in a object box local database. So if I was to close the app and open it again, all that information persists. Eventually this is also going to be filterable to the point where you can type in a name and dynamically filter the list based on the name, or you'll be able to select a category and filter the lists by that larger category as well. If you click on a chord, a minor chord for example, you will get a detail page that shows some more information about the chord. By default, it'll show the relative notes, which are the scale tones or the scale degrees that are used to build the chord. And if you know a lot about music theory, you can use that to extrapolate what the exact notes are that you would be playing in any specific key. Or you can let the app do that for you and just tell it what key you'd like to play the note in. And there's a F sharp minor chord, for example. This picture is being pulled from a web API, and it'll update dynamically depending on whatever key that I select. So that's one way of looking at chords. I'm going to have a favorites page that looks very similar to Explore and just has a list of the chords that you favorited. But I might know the notes in a chord and not know what the name of the chord is, or I might be able to play that chord on my instrument and not know what the name is. And so for that, we have a different mode called Identify, which has a couple of different ways that you can enter notes, the first of which is picking up my voice, so we'll switch out of that really quickly. This mode allows you to just enter the notes manually. So I can type in like A, C, and E, for example, reset it if I want to change the notes that I'm entering, throw in a sharp, and then as soon as I submit, it'll pull up that same chord detail page, but with a little bit of a difference. And then instead of starting with the relative notes, this drop-down actually has the key selected that I played the chord in. So since I played an A major chord, this is set to A, and I can still change the key if I'd like to see what that chord looks like in a different key. If I enter a note that doesn't exist, or a chord that doesn't exist, I can, I'll just get a toast that says no result was found. So that's how you can enter the notes manually. If you want to actually play the chord, you can do that as well. This will work with a piano or a guitar, or as you saw a minute ago, even your voice. And obviously this would work on a real instrument. I'm just showing you a virtual one so that you can see what I'm doing. So I'll switch over there and play a chord. And there we have our C sharp major 7. So that's pretty much the main functionality of the app. Probably the major challenge in building it was actually getting the pitch detection to work and the identification of chords based on those notes that are identified. So to get me started, I found a library which is able to take the microphone input on Android and get the frequency from it. And that library was really nice. It allowed me to just set up a callback function that gets the pitch in hertz, and I can do everything that I need to do with that. What it didn't do for me is go from the pitch or the frequency to the actual piano note. So I ended up writing quite a bit of code to do that and to interact with the musical notes in the different ways that I needed to. So I have this helper function note from frequency, which takes a frequency, returns, it gets the index of it, which is essentially the MIDI index, and then it indexes into a a list, which will give the actual note name as a string. Another thing that I should mention that got kind of interesting is the database actually doesn't store, like for example for the C chord, it doesn't actually store these notes. All that the database has is the relative notes for each chord, because typing in the notes manually for each key was going to be a lot of information to store, and that can be extrapolated dynamically from the relative notes, so I didn't want to have to store that if I didn't have to. And so a lot of what is in this pitch utils object is dealing with translating between the two different systems of representation, essentially. The relative notes and the strings, the notes that you would refer to on the piano or whatever instrument you're playing. So yeah, I have a lot of functions to do that. Another thing that was kind of ambiguous in a way that I hadn't thought about before is on piano and in music in general, accidentals, sharps and flats will actually have two names, like A sharp is actually B flat as well. But when we're searching for a chord from the pitch, we don't actually know what the name of the chord or the note should be. We don't know if we should call this note A flat or A sharp or B flat. That ended up being kind of tricky, especially since the information is only stored in the database in a relative sense. And so what I ended up having to do is create yet another system of representation, which is a 12-tone system. So instead of having like the sharp name and the flat name, I just assign a single number to each of the chords, or to each of the notes. And then before displaying it, I figure out whether it should be a sharp or a flat, and I translate it back to the system that people are familiar with. So in the database, we're actually storing chords in this 12-tone system. And this is my function that sets up the data to be queried from the database. There's a lot of comments in it about ways that I'd like to improve it. Right now, the chord has to be in first inversion. Essentially, the key note, the tonic, has to be on the bottom, and I have a lot of ideas about how to get past that. But long story short, for right now, what I'm doing is I'm taking in the list of notes, which comes in just like you're seeing when you enter them. Comes in looking something like that, and it can have sharps and flats as well. In the case of the listening mode, I do both the sharp and the flat name because we can't determine which one it is at that point. And so this function takes that, it converts it through a couple different steps, eventually to this 12-tone. First of all, it has to figure out what the tonic of the chord is going to be. Right now it just takes the bottom note. And then it converts it to the 12-tone system using that tonic, which eventually can be queried in the database because the database is storing the notes in that 12-tone format. And then, of course, once we get our chord, we have to translate our notes back to the regular notes. So that ended up being a really interesting challenge and kind of fun to explore how to translate this musical knowledge that I have into code and learn about these ambiguities that exist in a little bit of a different way than I could just with my musical sense. So that was challenge number one. Challenge number two was actually the web API that I used. It turns out this API is designed really nicely if you're a web developer, because they just give you a JavaScript file that you include on your website, and then there's actually an HTML tag that they have set up that will make the API query for you. So that's great if you're a web developer, but if you're a mobile developer, that's not great because we can't use HTML tags. So what I actually had to do was reverse engineer it a little bit. They didn't have any documentation about how to query the API, so I had to do some commenting in their JavaScript file and figure out what exactly the param string was that they were sending to the API. Got that and put it in retrofit, and then I was able to get a response back. But the response was also a little bit interesting because it didn't, it's formatted, as you can see, delimited by these RAR things, and it's not like a JSON or XML format. So instead of trying to let Retrofit parse that, I ended up just taking it as a raw string. And then, again, very nice for HTML, they just give you an image tag that you put on your website. So I just ended up looking in the string for the source, which gives me the URL of the website or of the image. And then I was able to grab that just from the raw text. Once I had that, I found another Android library which allowed me to make a request and display the image in a image view. So that part was super easy. And yeah, that is pretty much all the major functionality of Chordbook. Super fun to make. I was super excited that I actually got the pitch detection stuff to work in the end. And really exciting to actually use with a real piano and see it working. So yeah, that is Chordbook.